Hello, everyone. Welcome to our talk. It's going to be about our journey at Einride and how we build our vulnerability management program. So let's jump straight into it. My name is Anton. Before joining Einride, I worked at Spotify, KPMG, and played a bit of CTFs.
Hi, I'm Samuel. Before joining Einride, I also worked at Spotify. I've also worked at Cloud Query and several other companies, both in the US and here in Europe. But what is Einride? Einride is a global company with offices in Sweden and the US, and with operations in the US, the UAE, and a lot of Europe. We are an end-to-end carbon-freeing company that focuses on electrification for transport. So we do this by operating electric fleet of vehicles. We also have several charging stations around the world, including the largest in LA for heavy freight transport. We also work deeply with our industry partners, both operationally and in security, and we have a freight platform that makes it easy for people around the world to ship their products in a decarbonized fashion. Our end goal for this is to switch to the autonomous transport mechanisms that will allow safer operations as well as cheaper and better working environments for the drivers.
So a little bit more for you to understand, because we are here to learn about technical stuff. Our stack mostly consists of Golang applications, and everything is deployed into containers through various continuous deployment and continuous integration pipelines, so DevOps all the way. We mostly run everything in the Cloud Run. It's containerized protected by Google Cloud. But we also, as you could guess, run a lot of stuff on our vehicles. It's most of the time containerized stuff that runs in containers on some sort of Einride OS, we call it, in Kubernetes or something like this. So what we're going to talk about today is what is vulnerability management at Einride, what kind of parts it consists of, how it evolved over the time, what kind of vulnerability metrics do we use, and what we think about those. What kind of challenges do we see and still not solve it? And we come up with some takeaways.
So vulnerability management at Einride. We are currently supporting around 22 engineering teams. So these are teams that work both on our cloud solutions as well as on vehicle software. We're aggregating data across many vulnerability sources. So as we mentioned before, we have several different operating environments, and we have different sources to help us find about our security issues for each one of those. And our current standing today is we have around 60,000 vulnerabilities in our management today. So we have many different diversity of execution environments. So we have your normal environments that you might have at a normal company, so laptops and workstations. We also have a lot of cloud infrastructure, so we run our web services in the cloud. And we have office networks and servers that make up our day-to-day operations. We also have vehicles like freight trucks, autonomous trucks, and vehicle networks that we need to worry about. And newly, we have charging stations that have IoT charging devices, as well as networks that we need to manage remotely. So an overview of how our management system works is that we have a data source for each of our vulnerability findings. So for the cloud, we're using something called Orca Security, which is a cloud security and container security system, which reports vulnerabilities on the assets we have there. We also have DependentBot, which gives us information about our dependencies in code, and SymGrep, which gives us information about our application security in the code. And for our devices, we use something called CrowdStrike Falcon, which you guys are all probably familiar with, whether you've used it or you've heard about it in the news. So we have many different sources for many different platforms, but we want to manage them all in one single fashion. So I think all of these services, they offer a single pane of glass for developers. So if you're operating solely in the cloud, you can use Orca Security to manage your vulnerabilities for the cloud, but that doesn't help you if you have different vehicles or different environments like vehicles, which it wouldn't be helpful for you to have developers log into a cloud security system and then log into a different vehicle security system to manage their vulnerabilities. So what we've created here is a data management plane for our vulnerabilities. We're using BigQuery for our data fabric or our security data lake, but you could use whatever you'd like. So we're not here to talk about specific products, but more about how we approach managing our vulnerabilities in general. So once we aggregate all of our findings from these sources, we create dashboards and create notifications for different audiences. So one thing that you might encounter is, like, while these services offer a single pane of glass for dealing with one type of vulnerability, they're also focused on engineering. But we need to provide data-driven ability to make decisions to different audiences, such as leadership, managers, and the engineers. So here's an overview of one of our dashboards. This gives us a quick view at all of our security issues, whether it's in the cloud, code finding, or some other type of finding. And for each different type of finding, we have a different dashboard, which allows you to dive deeper into your findings. So here is an example of our cloud misconfigurations dashboard, which allows you to dive deeply into you or your team's security issues, and you can sort them by whether they're in different GCP projects or AWS accounts or anywhere. So we also track your vulnerabilities over time, and then you get a nice dashboard here where you can dive deeper into the issues. So another thing is about looking at a dashboard and seeing what is the overall overview of security, but we also want people to take action on their issues and deal with that in a timely manner. So we started off by having a Slack notification, which would tell everyone how many issues they have for each type of issue, as well as how many they have over SLA. So if you look closely and use your imagination, you can see how these categories in our Slack message correlate with the different sources and types of vulnerabilities that you may have. So now that we have a bunch of different vulnerabilities aggregated into one source, we also know that everyone has a different view about what is a vulnerability. So some vulnerabilities may not apply to us. We might have mitigating factors in place or something that makes a vulnerability irrelevant. We also might not always agree about what is the severity of a vulnerability. I know it's a very common topic in security to discuss what is the severity of a vulnerability, and in which cases would it be lower or higher. So we've created a tool here which allows us to manage this data in a code-oriented way. So we have a tool which allows us to exclude vulnerabilities or adjust the severity depending on different aspects. So there are three key concepts to our vulnerability management platform that we need to implement in order to have a unified tool that allows us to use all of our vulnerabilities in one place. So key is having resources. So in Google, you might have like a database or something like a storage bucket inside of a project, inside of an organization in the cloud. So what we've done is we've organized all of our resources into a tree, and on that tree we have different findings as well. So all of our findings have a kind of tree-like path, which relates a security issue to a resource. And on top of that, we have owners for all of our resources. And the owners are teams or individuals which own the resource. So then here we can have a end-to-end solution that allows us to route every finding to the owner of a resource. This requires us to have clear ownership for all of our resources. So in some places like clouds, it's easy to do this through tags and labels, but this is something you need to think about for every single vulnerability source. But because we have this tree-like infrastructure, which allows us to specify different rules on different parts of the resource tree, we're able to create inheritance and overrides that allow us to exclude some vulnerabilities for specific resources, but include them everywhere else deeper in the tree. So once we've created our vulnerability exceptions with this tool, everything is created as a YAML file, which then we can manage through our standard Git operations. So just like any other policy as code, we have a YAML file with all the details we need, and then we have GitHub, which allows us to have auditability and an approval process. So here we have like an exemption request. Engineering teams can make this themselves, or we can make it for them. And then we have a specific approval process depending on the severity of each vulnerability. once we create the pull request, we have similar CI tooling, which uses this tree to tell us exactly what this vulnerability exemption will apply to. So if you're approving an exemption request, you can see what is the actual effect of that request today. Additionally, these exemptions are tied to a time. So we can define an exemption today, and maybe this could be an example where we have a product which we're sunsetting. So while this finding is a proper finding with a real vulnerability and a real risk, the service that we're defining it on will be sunset in like a week. So then we can set an exemption process which takes this week into account, and if the service is not sunset within that week, all of the notifications will come back to your dashboards and your notifications. So this is where we started, but as we all know, feedback is the breakfast of champions. So we have a process where we continuously learn and evolve from our engineers' feedback. So we have a quarterly process where everyone will submit feedback to us, and then we will act on that feedback. So one example of improvements we've made is that engineers are overwhelmed with the type and amount of vulnerabilities that we have. So previously we had dashboards and notifications which would show you all the different categories and sources for your vulnerabilities. Now, if you're an engineering team who has normal production work that they need to do, it's hard for them to know, is today a day that we should fix a cloud misconfiguration, or is today a day that we'll fix a container finding? So what they requested us is to have a simpler system for their most important vulnerabilities that they can fix today. So we took their advice and we built a new system where we have focused recommendations. So here you can see in our new Slack system, we give them the 3 most important things that they can fix today. We also show them the severity of the vulnerability and the source of their vulnerability, and we help them define what should be fixed today. Of course, this also shows up in the dashboards. So we have a dashboard for every team with their vulnerability findings, but they can also look at and see how these findings change over time. So these are the findings for the September to the 12th, but they could go back in time and see what else could have been fixed before. So it might be that a new vulnerability comes out today, we have log4j v3, and that's important, but it might be a big effort, so they might want to look at other things to fix as well. The Slack posts are a great start, but it would be more fun to fix things if top-performing teams would be highlighted in the company. So we thought this was a great idea as well, and we created the Security Champions Leaderboard. So this picks 3 different metrics: the most closed findings, the most closed severity points, depending on the severity of the findings that were fixed, and the average age reduction in their finding age. So some vulnerabilities are been around for like a whole year. If it's a severe vulnerability that's been around for a year, it's more important for us to focus on that than maybe a new vulnerability that's fresh off the boat. So nice job, team. We also have a Security Champions Slack message to correlate with our dashboards. So we track the same metrics here, and we offer a link to look at the dashboards or the leaderboards whenever we send a message. So as you can see, we like to lead by example. We're here number 2. We'll be number 1 soon, I feel it. And the next is Security Fika.
Yeah, before proceeding, I'm really curious to ask you, who is an audience likes Fika? Please raise your hand. A lot.
Everyone likes Fika here. Are we in Sweden?
The next question is, what's your favorite bully? Yes, absolutely. It's like, the more bullies, the better, right? So what Security Fika is, it's a meeting we hold with, some engineering teams. We select somehow, we will talk about it in a moment, but we bring some Fika, we discuss the learnings from what team made, what kind of feedback we could provide as a team, what kind of feedback they have. So we change some advices, our views on the problems. So we exchange our opinions, and of course, with a Fika, so that makes everyone happier. And we do it with a team who is doing great, like I would say top performers. But we also select teams we think might have to look for opportunities for improvements in various areas. It's not necessarily a bad team. It's just a team who needs some help. And we enjoy meeting with them. Let's jump into the metrics then. So far, we're running this program for a bit longer than a year, and according to our data, around 88,000 vulnerabilities was fixed. You might think, oh, it's great. It's like we fixed thousands of issues. But on the other hand, as of today, we have 59,000 open. And that's led us to the thought that something is not really cool with it. So we dive deeper into the data and figured out that around 70% of our vulnerabilities owned by vendors. So vendors running their software in our environment. And we have not that much leverage over them because we cannot fix their vulnerabilities. It's their responsibility. And we have a number of those issues of those vendors. But on the other hand, we use it quite successfully as a leverage during negotiations with those vendors when we extended our contracts with them. So we were not only a blocker as a security team, but also an enabler, and we earned some money. That was a great win. So the idea of number of fixed vulnerabilities, calculating it, doesn't allow you to actually figure out, okay, there is a team who fixes it or who owns 100 vulnerabilities and a team who have to fix 20 vulnerabilities. Who we need to help first? Are they same? Are they different? But the teams are different, and one team might own only one service, which is old legacy. That's why they struggle with a lot of things with that service. But another team run all pretty new software. Everything is latest infrastructure. There could not be any issues with it. So it's really hard to compare teams by number of vulnerabilities. And it's really hard to see who is doing better or worse. So that's why we don't really, the dashboards what you saw before, they are for teams themselves. So they could see, oh, I have to prioritize this and that. That's what's my team's posture. And also as you could see it on this graph, I found it pretty interesting. Quite soon after we rolled out our vulnerability management program, we reached a sort of plateau of number of vulnerabilities our organization could fix in a day. So it's something to think for us as well. According to this data, it's like around 150 vulnerabilities a day. It's quite a lot. So what we use instead inside of our security engineering team to select to figure out how teams are doing, how a whole organization is doing, we focus on a bit more free two-dimensional metrics. Specifically on this graph is one of examples. So vertically, we see a number of vulnerabilities owned, was fixed by a team during the last 90 days, let's say. And horizontally, it's time it took them to fix. So because we own all the data, we could actually calculate when a vulnerability first showed up, when it was fixed, what was its priority, who owned it, what's the team name, what's the resource, etc. And the bubble size is average severity of vulnerability. You could notice that some bubbles are really small because their vulnerabilities are low severity. And if it's bigger, it's probably something worse, like high or even critical. But what we did, we just looked for outliers, and if it's something when it's a story, and we have to talk to that team and figure out what's their process. And we just learn a lot about their business. Another great thing was not only measure vulnerabilities, what was fixed, but also those what are currently exists, and we measure the average age of vulnerability, and the same approach as on the previous graph. So by doing that, we see not only how team performs in terms of how fast they fix vulnerabilities, that was the previous slide, but here we see their current state. So we could help them prioritize things and maybe address something earlier than later. With all that, we have still a few open challenges. It's hard to talk to vendor, sometimes because they have own business, and they own a lot of our vulnerabilities. We, of course, implemented different countermeasures to it. So like defense in depth and building fences around and borders around all the things that look sketchy helps here, but still doesn't feel right when 70% of your issues is somewhere else and you cannot do anything about it. Another issue that we faced is ownership attribution. So while we claim that we have a robust way to attribute certain vulnerability to certain team, it's a startup, and they do reorganizations here and there, left and right. They rename teams, they change ownership of services, and it's kind of struggle. So we have to be on top of all those updates and quickly improve and fix all our records. Another struggle is if you calculate just a number of vulnerabilities which are open right now, and each team will fix one vulnerability a day. It will take 1 year for them to fix everything. It's just impossible even to imagine how company will be able to do it. So for us, as a security team, it's an open question: what kind of other sort of programs we should run to enable those teams fix those issues faster? Maybe we could do something in our infrastructure in general, so we could fix it for them. So that's what we're looking for quite often, and that's what our work is around as well. The next one is that we rely on third-party tools to scan for vulnerabilities. Samuel mentioned what we run. We have Orca, SameGrab, Dependabot, etc. The issue we have with those is that they have their own understanding of a life cycle of vulnerability, when it's open, when it's closed. For example, if you delete some resource in Google Cloud, that's the cloud that we're using, some vulnerability scanners will still have this vulnerability open for a certain period of time and repeatedly report it back to us while it's still technically not exist anymore. And I mean, we have a valid concerns as a vendor to do so, but it's not really in line with what we are doing. That's just one of the examples. Also, we have a different understanding of what kind of severity to assign to vulnerability. So there might be some misunderstandings between vendor, us as security team, and feature teams that's going to fix that vulnerability. One final struggle is it's actually hard to do dashboarding and reporting because it's a human experience, and we are not UX folks. We are security engineers. We like terminals, but people like graphs and tables, I don't know what. So it's always a new learning every day. So what we've just went through, we went through how we set up our vulnerability management program, what kind of critical parts in it. We have exception systems. We have a communication channel set up. Everything is automatic. We have a gamification set for it. It all runs automatically. It's no manual work included, besides fixing bugs in it, obviously, and debugging it when people complain. But otherwise, it's our security engineering team quite small, so we have to automate everything. We discussed how our program evolved over the time, what lessons were learned, what metrics we used before and what we are using now, and what's ongoing challenges. So our critical components of something, if I will repeat building the same thing in a different place or again, it's first you have to have a robust asset inventory system. So you know what kind of resources you have, where are they, what's their status, are they alive? So if there is some sort of shadow IT or some server under the desk of engineer, you better know about it. Otherwise, it's a nightmare to track all of this. That should be resolved problem. In our crucial component is automated attribution of security findings to specific teams. So we have to know who is responsible for what. And it's not like one person is responsible for the whole GCP cloud. That doesn't work. That person should be, it's a team, because remember the bus factor? It should be a team who is able to fix something and do something about it. Next one, there should be ways to automatically communicate with teams. They have to have ways to get data without constantly talking to you. They have to have ways to provide feedback to you so you don't run around and asking them, oh, please go fix this. And they will complain, no, we think it's false positive, and we decide not to fix it. Everything should be automated. That's why we should have a robust exception system that is quite flexible for your setup. Obviously, everything will not work if engineering teams have no time doing that, and business, as a stakeholder of all this, doesn't support it. So this should be working as a whole organization, and you should have a buying from all levels, from bottom to the top. And I think last but not least, crucial component is your risk appetite. The risk appetite of your vulnerability management program should be in line with the business you're running. So imagine a startup like we and a military defense contractor. I guess security requirements are way different. And while we could accept having thousands of vulnerability open, and we still have defense and dev and countermeasures here and there, so it's not like welcome everyone, but still it's quite significantly different situation if we would run a submarine factory plant, I don't know. So we should adjust our approaches. And that's it. Samuel?
Yeah, I think if any of you guys are dealing with these problems yourself or have any questions, please feel free to reach out to us on LinkedIn. And thank you for coming to our talk.